Good morning to you all. It's me, Indramani Gewali, math facilitator. So, like in our previous class, today, I'm going to discuss the same topic, factorization. So, let me just recall what did we learn in our previous class. So, in previous class, we discussed about some factorization, and we also discussed about what is factor, what is factorization, what is the difference between them, and what are polynomials, and so on. So after that, we practiced some of the questions of factorization by grouping the terms. Here, today's main objective is we will be discussing some factorization today, which are based on a squared minus b squared form. So expression of the form a squared minus b squared is today's main objective. Expression of the form a square minus b square. So this is today's main objective. So based on a square minus b square form, we are going to learn some factorizations. So you can see the questions now. So I'm going to write some questions. Let's see the question at the same time on the slide. Before I write, I take some questions for today's class. Here, I am also going to discuss what are the factors of a square minus b square and what is the major difference of factors and expanded forms in some of the formulas. So first question, let me take a question, x to the power 4 minus y to the 4. Here, what we need to understand is, let me take an example, a plus b whole square. We know what is its formula. Its formula is a square plus twice ab plus b square. This is called expanded form because here, what is the original expression? A plus b whole square. It is expanded into three terms, a square 2ab plus b square. So we call this is expanded form. Similarly, it has factors. What are the factors of this algebraic expression? Its factors are a plus b times a plus b. So the factors are algebraic expressions that divides another expression or polynomial exactly without any remainder. So factors of a plus b whole square are a plus b times a plus b. When we multiply these two factors together, we will obtain the original expression. This is a plus b whole square. So here I'm taking one expression. This is x to the power 4 minus y to the power 4. And this is, we can transform this expression into a square minus b square form. We can transform this into a square minus b square form for its factorization. Let's see now, how can we transform this? Can we rewrite x to the power 4 like x square whole square? Because if we multiply two exponents here, x to the power 2 times 2, so 2 times of 2 is 4. We will obtain x to the 4 minus y square whole square. Now it is in the form of a square minus b square, where the first term in a bracket is x square, and we can consider this is a, we can consider this is a, and this one is b. So it is in a square minus b square form. What are a and b? We can simply look at the bracket. A is x square and b is y square. So what are the factors of this expression? What are the factors of a square minus b square? So factors of a square minus b square are a plus b times a minus b. We know this. Since a square minus b square, its factors are a plus b times a minus b. So here, by comparing this expression with a square minus b square and using this formula, this factors, we can factorize this expression. So let's factorize now. What are the formulas? What are the factors of a square minus b square? These factors are a plus b and a minus b. So what is a? X square. So x square means a plus y square is b. So a plus b times a minus b. Here a is x square and b is y square. So x square minus y square. Still we can further factorize this, because second factors, again we can convert x square minus y square into factors a plus b, a minus b. So let's factorize this second term, second factor. So x square plus y square times, what are the factors of x square minus y square? X plus y times x minus y. So these are the factors of x to the power 4 minus y to the power 4. Now y, we are not factorizing x square plus y square. So it seems x square plus y square is in a square plus b square form, and it has expanded form a plus b whole square minus twice ab, or a minus b whole square plus a minus b whole square plus 2ab. So if we try to factorize x square plus y square, we obtain this expanded form. But if we insert 2ab, this term 2ab in square root, we can factorize, but we do not do that. So these are the factors of the expression x to the power 4 minus y to the power 4. So similarly, let's take next example for factorization. Example number 2. We can take here the question x square plus 2x minus y square plus 2y. Okay, now let's try to factorize this. So this expression has 4 terms: x square plus twice of x minus y square plus 2y. Now if we simply try to take common from first 2 terms and next 2 terms, let's see what we will get. But I'm not sure whether we can factorize just by taking first 2 terms and next 2 terms. But in the first step in factorization, we try to find common factors like any numbers or letters from throughout the expression. Then we try to rearrange by grouping the terms and we proceed. If we simply take common from first 2 terms and next 2 terms, let's see what we will obtain here. What is common from first 2 terms? X plus 2, because after taking x is common, what is left? In the first term, x positive sign as it is, and in the second term 2, minus what is common from third and fourth term, negative y, and the remaining terms are y minus 2. Because if we multiply minus y times y, we will obtain minus y square. So minus minus becomes plus, and y times 2 times of y is 2y plus 2y. So can we factorize this? Let's see the term in the bracket. X plus y and y minus 2 are 2 different terms. So for the factorization, so these 2 terms in the bracket must be same. Otherwise we cannot factorize. So by simply taking common from first 2 terms and next 2 terms, there is no possibility of factorizing this expression. So let's think now how do we factorize? How can we factorize this expression? For this, we need to rearrange the terms. So if we rewrite here first term with third term, if we put first and third term together, x square minus y square, and second and fourth term plus 2x plus 2y. Now let's try whether we can factorize this or not. Let's try this, because in factorization there is no exact rule. There is no hard and fast rule in factorization. So sometimes we take common from all the expressions, all the terms, if there is common. If not, after that we will try to convert into any of the formula by rearranging the terms. This is called grouping by factorization. Factorization by grouping. So here we can split first two terms into a formula, because first two terms, x square minus y square, can be converted into x plus y, x minus y, because its factors are x plus y times x minus y plus. Now from these two terms, what is common? We can see here 2 is common. So what are the terms left? X plus y. So it seems one of the factor is again common. If we consider this is our first term and this one is second term, what is common? The common factor is x plus y is common. So we can take x plus y common, and what are the terms left in first is x minus y plus in the second term 2 is left. So we factorize this. So in this case, in the first step, we need to find if there is any common factor, number or letter from the expression. If not, we will try to rearrange the terms in suitable group such that each group has a common factor. And there are other processes. We will slowly discuss other types of factorization. So these are the simple types of factorization. Here we discussed about how do we factorize this by rearranging the terms, or factorization by grouping the terms here. So similarly, now we can take other examples for the factorization. Let's see some questions on the slide, and let's do one of the question which is similar with this, which is again in the form of a square minus b square. So here in factorization, some of the points are very important, like what are factors and expanded forms, what is a perfect square, how do we convert some of the terms into the perfect square, or how can we convert them into the formula. So let me take another example here. Let me take third example, number 3. Example number 3 here is x square minus z square plus 2xy plus y square. Again, this expression has 4 terms. Now it's almost similar with previous number, but we will try to convert this into a perfect square for factorization, and then at the end we will convert into a square minus b square form. So can we factorize this expression simply by factorizing first 2 terms and next 2 terms by taking common? I don't think so. So let's try to rearrange the terms here. If we rearrange x square with 2xy and y square, let's write x square plus 2 times of xy plus y square minus z square. Here, now first 3 terms, it seems it goes into a formula. X square plus 2 times xy plus y square it is same as a square plus 2ab plus b square. A square plus 2ab plus b square. A square plus 2ab plus b square. So we know what is the perfect square. Can we convert x square plus 2xy plus y square into a formula? Yes, obviously we can. So what is its formula? Formula of a square plus 2ab plus b square is a plus b whole square. So what is a here? X. And what is b? Y. So it is x plus y whole square minus the last term as it is, it's z whole square. Now let's factorize again. Now we know what is a square minus b square. What are the factors? A plus b times a minus b. So these are the factors of a square minus b square. Now it seems the first term in the first bracket, x plus y, if we consider this is a and this is b, a is x plus y and b is z, it is in the form of a square minus b square, and we can split into a plus b times a minus b form. So what is a? So here a is x plus y, and what is b? B is simply z. Now let's factorize this. So I'm writing here. So a is x plus y, so this is a plus b, so x plus y plus z times a minus b, x plus y minus z. So a is x plus y, b is z, a is x plus y and b is z. So these are the two factors of this expression, x squared plus 2xy plus y squared minus z squared. So these are some of the examples of the factorizations in the form of a square minus b square, where in some expressions we try to rearrange the terms and we convert it into a plus b whole square form, and then we again changed into a square minus b square form for the factorization. There are many expressions we can factorize. There are many algebraic expressions we can factorize them. So let's take next question for factorization, which is again in the same form, a square minus b square. Here we are discussing basically the expression which are in a square minus b square form, which are in a square minus b square form. So let me take next algebraic expression for factorization. It's a square minus b square plus 4b minus 4. Okay, let's think now. What is the difference between this expression and the previous? Can we factorize this expression by splitting first two terms into formula and taking common from next, or not? If not, what is the process? Let's find out. Let's try to rearrange, or what should we do to factorize? Either we can take negative sign common from here, or we can simply factorize by splitting the terms by rearranging. So let's say this. Let's try. If we simply try to split first two terms into formula, like a square minus b square into a formula, a plus b, a minus b, and taking 4 common from third and fourth term, let's see what we will get. A square minus b square, its factors are a plus b times a minus b. What is common from here? 4, b minus 1. So can we see here any factor common? A plus b, a minus b, it is b minus 1. So none of the factors are common. So this process is not the correct process for the factorization. Here I'm explaining why cannot we factorize this by simply splitting first two terms into formula and taking 4 common from next two terms. Now let's think. Can we factorize this expression by rearranging the terms? Like arranging a square and negative 4 and b square and positive 4b? No. So what is the process of this? What is the process of this? So let me take negative sign common from second term here. So a square minus, if we take negative sign common from the second term, then we can convert the term of the bracket into perfect square, and then we can again convert into a square minus b square form, because we are discussing the factorization of the form a square minus b square. So at the end of the factorization, we will try to convert into a square minus b square form. So here, so I'm taking negative sign common from second term. Let's see what we will obtain. So after taking negative sign common from the second term, now sign of these three terms will be changed. So negative b square will be positive, so positive 4b will be negative 4b, and negative 4 will be positive 4. We can try this, why the sign are changed in the bracket. For this, we can check it. If we multiply negative sign with b square, negative sign with b square is minus b square. So minus minus plus, minus minus plus 4 times of b. So minus plus is minus 4. Okay, so here, now just look at the bracket. Look at the bracket and let's try to convert these three terms into a formula, perfect square, or let's try to factorize this. So for this, let me write over here b square minus 4 times of b plus 4. How do we factorize this? Now for this, we simply can split the middle term. We can split the middle term. While splitting the middle term in any expression, what we need to know is, let's find two numbers. While splitting the middle term, let's find two numbers whose product is the product of coefficient of b square times constant term. So what is the product of constant term 4 and coefficient of b square? 4 times of 1 is 4, product is 4, and sum of two numbers should be 4. Product is 4 and sum of two numbers is again 4, because this positive sign determines sum and coefficient of middle term is 4. That's why sum should be 4 and product is 4 times of 1 is 4. Can we simply think what are two numbers whose product is 4 and sum is 4? It's simple, 2 and 2. So we can simply factorize this. B square minus 2b minus 2b plus 4, because negative 2b is negative 4 times of b. Now can we take common from first two terms and next two terms? Let's try this. What is common from here? B is common, so b minus 2. Negative sign is common from third and fourth term. Can we take 2 common? Yes. Negative sign with 2, minus 2. If we take negative sign common and 2, now what are the terms left? B minus 2. Because minus 2 times of b is negative 2b, minus minus plus 2 times of 2 is 4. Here we can see b minus 2 is a common factor. So b minus 2 times b minus 2. Here are two factors which are same, b minus 2. So can we write this like b minus 2 whole square? Because I have explained what are the factors of a minus b whole square. What are the factors of this? Factors of a minus b whole square are a minus b times a minus b. So if we multiply these two factors, obviously we will obtain a minus b whole square. We will obtain this original expression, a minus b whole square. This is the perfect square. So b minus 2 times b minus 2, this is b minus 2 whole square. So we need to factorize this term, 3 terms which are in the bracket, by splitting middle term. There are many ways. So the common process, we say we split middle term for this factorization, or directly we can convert this into a minus b whole square form. So let me go ahead and write the next step. So a square minus b square minus 4b plus 4. So I have done here, I have shown here at the side the process of factorizing b square minus 4b plus 4. So I am writing directly here. So b minus 2 whole square. How? B minus 2 whole square is derived from b square minus 4b plus 4. It's here. Okay, we can say this is the process that we follow. Now it's again, this is in the form of a square minus b square, where a is a itself, where capital A is here a and capital B is b minus 2. Now we know what are the factors of a square minus b square. The factors are a plus b times a minus b. Factors are a plus b times a minus b. So these are the factors of a square minus b square. So what is a? Capital A, it's small a, and what is b? B is b minus 2. So let's try to convert into this formula, a square minus b square formula. Okay, so this is a plus b. So what is a? A small a, plus what is b? B is here b minus 2. So b minus 2. So we can write this in curly bracket. This is the first factor, a plus b. Similarly, now what is the second factor here is a minus b. So a is small a minus what is b? So b is the second term in the bracket, b minus 2. Just let's simplify this. A plus b minus 2 times a minus, we can open bracket with negative sign, so minus b, so negative sign minus minus becomes plus. So these are the two factors of this expression, a square minus b square plus 4 times of b minus 4. Here, first of all, we tried simply by splitting first two terms and taking 4 common from next two term, but we could not factorize. I explained why, because nothing was common from first and second term. So that we used another process and we took negative sign common from second term, and we are able to factorize this. So there are various ways in factorization. There are various types of algebraic expressions in factorization, and this is one of the most important lesson, factorization, because in algebra, whether we are simply finding factors or simplifying any algebraic expressions or finding HCF and LCM, everywhere there is use of factorization. After knowing factorization, we can easily move ahead and simplify any algebraic expressions like simplification or HCF and LCM. Saying this, let me end the class here. Thank you all for watching and have a wonderful day ahead. Thank you all.